welcome to the TechSnack. I'm pretty happy to see you. It's good that you had that you postponed your plans to just enjoy this snack, and I hope it will be useful for you. And today we're going to talk about MVC, and not only MVC, we will cover the whole family of patterns, and also we'll go beyond, even beyond of that. So let me start from the problem first. Like maybe you had this on your question on your interview, or you just thought of that, like what's the real difference about MVC, MVP, MVVM? If you Google the internet, you can really find like some shell of documents about that, but not really a good explanation. Maybe you don't know what's the difference between those patterns. For me personally, I had a hard time understanding the difference between MVP and MVVM. Also, have you ever thought like where those patterns are today, like where they used, why we don't see much talk about MVC? Like, I mean, we see talks about MVC, but not in the real code, right? And that might be a surprise to you, but do you know that Redux and Flux is actually related to MVC? You often find talks where people discuss MVC, MVP, MVVM, and Redux and Flux, but as a separate patterns. Like you won't see a talk where they talk about those patterns like they evolve together. So hello, my name's Stepan. I'm lead software engineer at EPAM Systems, and today I'm going to teach you MVC, and I'm going to do that in that way that whenever you ask this question on interview, you're just going to crash the interviewer with your knowledge, so he will regret that he asked you this question. We will go through each of the pattern one by one, looking at their components, how they implemented in the code, and some pros of the cons. I want to point out that the examples I prepared strictly focuses on the idea of those patterns, and they also may vary depending on the implementation, because over time lots of variation of these patterns emerged. So if you find that some of that is different than you used to, or you read something different, that's fine. If anything, ask your question in the chat. We can discuss this later after this presentation. Let's start from model view controller, short MVC. So let's discuss what is a model. So the idea is that it's actually a central component of the pattern, and why the reason for that is because model is the real crucial part of this pattern. Like it handles logic, it manages data, and basically the business rules of the application. So like everything you write, you will every logic, every communication to backend, for example, you will write here. So the view should also contain business logic. And I got you there. Never write your business logic inside view. Never ever in any situation, view should not contain business logic. But except, like instead, view should represent the data. So the idea of view is it only takes the data from model and displays them. That's it. And maybe when user interacts with the view, it will interact with controller, like invoke some method on controller, but it won't directly invoke any method on the model. And the specific of this pattern is that view also has a model, usually has a model as dependency. As you will see on the diagram, it will be a cyclic dependency. So controller, it not that hard here. Like depending, again, as I said, depending on the implementation of this pattern, you may encounter some implementation where business logic was put inside the controller as well. But in this case, we're going to put logic in business logic, in model, and where it was originally intended to be. And controller simply accepts some inputs from view and invokes appropriate method on the model. So let's see how this looks like on the diagram. So what happens when user, for example, clicks a button? Well, view will notify a controller. Controller will invoke appropriate method on the model, and model will update the UI. Simple, right? Notice this cyclic dependency. So today we're going to build like the code examples focuses on building this piece of UI. We will have just one input where we're going to input our to-do items and we will delete them. That's it. Only two actions: add and remove. So UI looks simple. So we have just only one input with a button. And for list, in case you're curious, it's a mustache template. So it basically says iterate over list and displays it for each item in the list. So it also just a label and a button. So model looks like really in this implementation, model is not that hard. Like we only have a list of items. In this case, we have some initial value. You can imagine that you get in this from local storage or some other third party. And also we have method to work with this data. In our case, we have get list to retrieve the list of items, add and remove item from this list. And also notice those methods. So why that? Like the view needs to tell, like not tell, but needs to register itself on the model. So whenever model changes, we need to invoke. We will invoke this method, and this method will simply redraw the view. Again, let's walk through view. So as I said, when we create a view, we will register our callback on the model. So whenever model updates, it will call this callback. In our case, we will simply call the render method. And notice that we inject the model inside the constructor of the view. So view really has a reference to the model. Now render method. So again, we get the template from the previous slides, and we render this passing this list. Notice that here we directly invoke the method on the model. So when I said like you don't need to invoke any method on the model, I meant like you don't need to invoke any method which can delete or remove or do something to business logic, but you can safely invoke those methods which simply allows you to retrieve the data. And the same way as with model, we have methods to register callbacks from controller. Now let's look at this attach event handlers method at the bottom. So it simply gets attaches event handlers to the button and to the delete button. And as you can see here, we simply invoke the method which controller will pass to the view. So controller. We create a model and view. Also, we pass model to view. And as from previous slide, we invoke our handlers. Like we say, whenever user passes add, invoke the add method on model, and whenever user passes on delete, we also will invoke remove method. And also we render the view. Entry point is just we create new controller and our application works. So what's special about this pattern? Well, we have a separation of concerns. So our code is organized. We have logic for model. We know what should go into controller and what should go into view. Hence, it leads to better code organization and maintainability. But as you saw from the diagram, our elements are tightly coupled. So we have this cyclic dependency. And this will lead to harder unit testing, and you will need to mock a lot of methods. So that's where Model View Presenter comes in. It's here to resolve the issues of MVC. So model is the same, won't stop here. And in MVP, you should put now your business logic inside view. And again, don't do that. Never do that. Don't put your business logic inside view in any pattern. So actually, the role of the view is the same, but now it won't have this dependency between view and model, but rather view will communicate only with presenter. And presenter is the same controller, except it's now will act as a mediator between model and view. So how it looks? So user presses a button, view will notify a presenter, presenter will invoke some method on the model, and model will tell the presenter that it was updated. And presenter on next will invoke, like it will tell the view to redraw itself. So model now even simpler because we don't have to register any callbacks here. And view is really almost identical to the previous one, except notice this, we don't have any dependency and we pass the list of items as a parameter. So here's the key difference between MVC view and MVP view. Okay, let's move forward. So presenter, the idea of presenter is the same as in MVC, but as I said, it now has to manage a view. So again, we create those two entities and also register event handlers. But now, whenever we add or delete item, we will manually tell the view to redraw itself. And also notice that we getting the data from the model. So now presenter is really like a middleman between those two. The entry point is the same, but now it's presenter. So what part of this pattern? It's less coupling compared to MVC, and hence it's easier to unit test. But as a cons, it's like now the presenter has more responsibility on itself, so it becomes kind of bottleneck, and it's easy to mess up with presenter. I wouldn't say it where model view model comes in, but rather MVVM, it's not the logical continuation of MVP, but it's rather different implementation, like different improvement of MVC. So model is the same, but now in view we will put our business logic. And I got you again, don't do that, never. So view compared to MVP, for example, it's the same visual representation of the data, but now we will have two-way data binding between view and view model. And now Angular guys thought like, hey, I know what data binding is, yes? Yeah, it's similar like in Angular. So we will have this kind of communication between view and view model. But what's so special about this, we won't have any reference to view model here at all. So view model simply has components, commands and props which view uses. And again, it doesn't have any reference to the view. How does it look like? Again, we press a button, view will update view model. View model will invoke some method on the model, and model will be updated, and it will notify view model. And hence view model will update view. Looks similar as in MVP, right? But no, we have this two-way data binding mechanism. Don't forget that. So whenever view is updated, it will always update the same data inside the view model. And whenever view model is updated, it will also update the data, like redraw the view. So how to achieve this? So in JavaScript, we don't have native two-way data binding mechanism. So you have two ways. You either need to use a framework or you can implement your own solution. And just for the sake of this example, I decided to create my own mini framework. Don't worry, I will explain everything. So we need to update our view now. We will add this data bind, data on, and data for each attribute to our elements. And take a moment to have a look at view model. It actually looks pretty similar to Angular component. So we have just our data, we have list and some items. Let's see how they bound to the view. So for new item value property, we bind it to our input and we say, whenever this input changes, bind new item value property from view model to the value of view, or to the value of input. And the same way here, like whenever user presses this button, invoke this method. So what about list? Same here. We bind it here. We say iterate through the list of items and display them. And whenever user presses delete, invoke this method and pass this as value to the method. So for the sake of, just for the sake of the example, I left this class view, but it's really not needed there. We can have only HTML and not note this bind template method. It's what I said. It's custom implementation to bind the properties on the view model to the HTML. Later I will share the code, but please don't use it in production. I did this just for fun and for the sake of this example, for the sake of this presentation. Okay, so what are pros and cons of this pattern? So we have even better loose coupling, and hence it's even more easier to test. But usually, well, not usually, always it requires a framework. So for example, Knockout is purely MVVM framework. In case you're curious, you can check this out. So, and framework means that you need to learn some stuff. Okay, now once we covered those patterns, so what's wrong with them? Like, looks great, especially this MVVM, right? Well, to answer that, let's review a bit. So whenever user interacts with view, controller, and model, it looks perfect, right, on the diagram. But in the real life, we have more entities. So let's say what happened when user interacts with view at the bottom. Well, its model will be updated, and this model may need to update some data in this model. And this model, as a result, will update some data back. Okay, now we need to update this model. Okay, this model needs to update this model, and this model needs to update here. So now we finally updated. Now some set timeout happened and we updated again. So you can see where I'm going with this, like managing like the state and synchronizing the state in MVC patterns can be hard. That's why we need something better. That's where Flux come in. So the idea of Flux is really to address the issue of MVC patterns and to like synchronize the data. So how does it look like? So we click a view, user clicks a button on the view. View will create action and dispatch this action to dispatcher. Dispatcher will notify the store and store will update the view. So now take a closer look. Does this really look familiar to you? Like, remember the MVC diagram. So what if I tell you that this action on this diagram is really redundant? So we can update the diagram, and what we have here, it's actually MVC. It's the same idea, and you will see it later. But now, if it's the same idea, what's the difference? Well, to answer this question, we need to add, again, more entities. And now you can see that the dispatcher is actually a singleton. And when user presses a button on the view will create action and dispatch it to dispatcher. Dispatcher will notify the store and store will update the view, right? But also dispatcher will notify other stores so they can update their view as well. So in the code, it looks like the following. It should be really familiar to you if you worked with Redux. You have just action with some type and payload. Also view. We create new instance of the store inside the view because we need to reference it. And we say whenever store changes, render the view. And also we initially render the view. Again, it's the same idea as in MVC. And we just also passes the list of items to when we render. So attach event handlers method looks almost identical to the one in MVC. But now we, instead of invoking some methods, we dispatch new action to dispatcher. Let's look at the dispatcher. It has a list of stores, so it needs to track the stores to update. Also, just for sanity, we have this check to make sure that dispatcher is a singleton. Also, we have this register store method, which store will, like whenever we create new store will call this method and push itself to the stores array. And also dispatch method, which will iterate through each store and call on dispatch method. It's simple as that. So store. Whenever we create store, as I told you, we register its instance on the dispatcher. And we have also this on dispatch method. Pay attention that it really looks like a reducer if you all worked with Redux, and it's really hard. So whenever now the same idea as in MVC, whenever our store changes, we will call this method to redraw our view. And the entry point now is view. We create new view and everything should work. So because of this pattern, it's easier to manage multiple stores, but you still need to manage multiple stores. Like we can take this idea even further. That's where Redux come in. Let's look at the diagram. We press a button, view will again create some action. Action will invoke a reducer. Reducer updates store, and store will update the view. Looks the same, right? Again, let's introduce new entries to see the difference. So now, as we can see, the store is a singleton. So we presses a button on the view. View will create action, passes action to reducer. Reducer will update store, and store will notify all the views. So in the code, it looks like the following. The reducer is not that hard. We have just pure reducer, which takes some state action, and depending on the action type, it will add the item to the state or remove the item from the state. Also store, yeah, it can look like lots of code, but actually it's not that hard. The idea of the store should be familiar to you if you worked with Redux. Again, we have just some check to verify that store is a singleton. We have this emit store update functions array to track the list of the views we need to update. The same as we had in dispatcher, but now we need to track the views inside. In dispatcher, we track the stores, but now in the store, we will track all the views. And also we will have, like as you know, a store can be divided to, it can be divided so we can have multiple reducers. Now let's look at the dispatch method. So on dispatch, whenever we dispatch, we will reduce through reducers. And yes, now you know why reducers called so. And reducers, we will invoke each reducer passing the previous state and an action. And as you can see, in the end, we will have a new state. And when we have a new state, we will iterate through each views and update it. Yeah, it may be not that efficient, but again, it's just demo. So entry point, we just create register new reducer on the store and we create a view. So pros of this pattern is that it's easy to manage single store. And in this case, I didn't find any cons, and please don't hate me that I didn't mention the real problems of Redux, like this boilerplate issues, but we want to focus only on the differences between those patterns. So in the summary, we can say that whenever you asked about this pattern, you can say that the idea of MVC is circular dependency between the elements. In the MVP, you have less coupling compared to MVC by removing the dependency between view and model. In MVVM, you have, it's like, it takes the idea even, like it even improves the idea. So now we don't have any dependency between view and view model. So you have two-way data binding between them. And Flux simply tries to fix the issues of MV family of patterns by having dispatcher as a singleton. And Redux take this idea even further and has store as a singleton. Yeah, so thank you, TechSnack team and JavaScript Competency Center for organizing and preparing this TechSnack. In case like you're curious, you can join us. You can find us on YouTube. Please subscribe to YouTube and our Instagram channel to not miss any further events. And here you can find code samples to play with them in case you're really curious. And now I can check some questions and we'll answer them. Let's see what we have there. I see question. If backend application contains only API which returns JSON or XML, in which pattern it will be like? So we covered here only SPA patterns. Like we have also MVC pattern for backend, but I didn't touch that here. And if you simply have backend which returns JSON, I don't know, it depends on the idea you need to use. But again, we talk about front-end side here. Maybe we should start putting business logic to use. Yeah, maybe you can always, like, take idea other side and implement your new pattern. Maybe it will have some success, who knows. Yes, so I see that we really don't have any questions. Yeah, so thank you for joining. Thank you for being patient to wait for the presentation. And I hope it was really useful for you. You learned a lot of stuff. I did certainly when I was preparing this TechSnack. Feel free to play with code examples and I will see you in the next presentations.